So in this problem, we are supposed to implement the cache pset, the cache problem, but instead of C, we're going to use Python. So let's start off with taking the input from the user. So I'm going to take input from the user. So I'm going to say get underscore int change ode, something like this. And then what I'm going to do is I'm going to store this inside a variable called dollars. Okay. So now what I'm going to do is I have to continuously, repeatedly ask the user for this input until I get my required input. So I don't have a do while loop in Python, but I'm going to use the while true or an infinite loop. Okay. And what I'm going to say is I'm going to see if the input that I receive, if it's a valid input. If the input is valid, then I'm going to break out of this loop. Okay. Oops, I'm going to break out of this loop. And then finally, I'm going to say sense equals, I'm going to say I want to calculate the sense. So to get that, I'm going to multiply this by 100 and then I'm going to round this up. Okay, I'm going to round this up. The round function, what it does, it takes in a number, multiplies it by 100, and then we round that to the nearest integer. Okay, why are we doing this? Because of some floating point imprecision values, right? So numbers that are stored inside any program, okay, they are susceptible to floating point imprecision. So to avoid all the imprecisions and errors, we need to round this dollars times 100 up to the nearest integer. So after doing that, there's one thing that we need to do is we need to import this from CS50. From CS50, I'm going to import get underscore int. Okay. So then after doing that, I'm going to say, you know what? I'm going to store the number of coins inside a variable called coins. Okay. And I'm going to then use the same logic that we use in the C program. I'm going to say while it's true, I'm going to repeatedly subtract a quarter. I'm going to repeatedly subtract. As you can see over here, I have a quarter, I have quarters, I have dimes, I have nickels, and I have pennies. So we had discussed three methods in the previous problem, which is problem set 2. We had discussed how we solve this, but I'm just going to repeat it quickly. What I'm going to do is until this sense value, so I have something like, let's say I input 0.41, then I have 41 cents, right? So what I'm going to do is I'm going to keep on subtracting 25 from this until I get till this value is greater than or equal to 25. I'm going to subtract 25. So that's what I'm going to do. I'm going to subtract 25 from this. Okay, and then I'm also increase the number of coins by 1 every single time. So I subtract 25 once and I increment this coins by 1, so it becomes 1. Okay, and then we can see once you subtract it one time, the value of this is going to be 16. Which is going not greater than or equal to 25. So I can't continue. So therefore, I need to look at the next denomination and do the same thing. I'm going to subtract, after subtracting 25 or quarters, I'm going to move on to the dimes. I'm going to subtract 10 cents. Okay, same thing I'm going to do, but instead of a quarter, I'm going to use dimes. Okay, so I'm going to subtract 10 cents. So I subtract 10 cents over here. I increment this coins by 1. So the value of coins is incremented by 1 to 2. Okay, subtract it one time and I get the value of 6. So then I go back over here and I see while the sense is greater than or equal to 10, I find out that sense is not greater than or equal to 10. So I break out of this loop. Okay, so in a sense, I have used 2 coins right now. Okay, now in the next step, the same thing is going to happen. The same logic is going to repeat itself, and I'm going to say I need to subtract 5, right? Okay, so I am increment coins, and let's say I subtract 5 one time, and then I figure out the answer is going to be equal to 1, which is obviously greater. It's not greater than or equal to 5, so I break out of this loop. So once I break out of this loop, what I'm going to do is I'm going to use the same logic, and I'm going to decrement the cents by 1 and increment the coins by 1, plus equals 1. Okay, this is one way of doing this, right? So now what I'm going to do is I'm going to print out the number of coins. Okay, and if I run this program, to run the program, I'm going to say python cache.py, and then followed by, okay, I'm just going to change this, change ode, and give it a proper formatting, and I'm going to just quit out of this. So change ode. What is the change ode? $0.41. Oops, $0.41. Okay, if dollars is greater than or equal to 0, I break. Okay, So I should break. Why am I not breaking here? Well, the reason I'm not breaking it here is because I'm taking an integer. I need an integer here. I need a floating point number here, but I'm taking in an integer, which is the wrong thing to do. So I'm going to get a float over here, right? I'm going to get a float over here. I'm going to exit out of this, and I'm going to say 0.41 over here. So as you can see, I get the answer is 4. This is one way of doing this problem. Yeah, there are multiple ways of doing this. Now, one of the ways in which this program is actually hurting us is we are constantly repeating ourselves. We are copying and pasting, which gives us a hint that we might be able to do better. We might be able to do better. So one thought is pretty simple. Only this part is changing, right? So what if I store all this inside an array called denominations? So I have an array over here called denominations, and then what I do is I store all these denominations, 10, 25, 5 and 1. Okay, and then what I do is I can just say, you know what, for every, as you can see, this was this thing needs to be repeated like 4 number of times, right? This piece of code. So what I'm going to do is I'm going to write a genetic code. Okay, I'm going to write sort of generic code over here. So I'm going to say while sense is greater than or equal to, let's say denom. And where will I get the denom? I'm going to get the denom from this array. So I'm going to say for denom in denominations, I'm going to run this while loop over here, and then I'm going to say sense is minus equals what? The denom. Okay, and then coins needs to be incremented by 1. Essentially what I've done is, by just adding this one line and this one sort of abstraction over here, okay, what I've been able to do is I'm able to remove all this, and what I have is a simplified, more readable code. Okay, so now if I run python cache.py, I type in 0.41, I get this. Okay, now there's one more way of doing this, third way of doing this, which says, you know what, instead of having 2 loops over here, I can be done with 1 loop. How can I do that? Well, what I'm doing here is I'm subtracting denomination, the value denom, which is 25, 10 or 5 or whatever. I'm subtracting that from this variable sense. And I can avoid that because I'm just repeatedly subtracting, right? From a particular variable, I'm just repeatedly subtracting. Now, instead of doing that, what I can do is I can think of an operation which is pretty similar to repeated subtraction, and the answer to that question, to the question of what operation is very similar to repeated subtraction, is division, right? So for example, what I'm doing here is I'm just subtracting 25 until you know, this value is getting less than 25, right? So instead of doing that, I could just say 41 divided by 25, and the answer is going to be 1. Integer division. I need to divide it in this form, right? When I divide 41 by 25, I get 1 followed by some remainder. A remainder of what? A remainder of 16, right? So this is the format which is very similar to keeping on subtracting this value 25 again and again. So thinking about that, how can we do this? So the way we can do this is we can say, you know what, instead of doing this, and instead of incrementing by 1, I'm going to increment the value, the coins value, by this, right? So this amount. So if, for example, this was like 61, I would have got, you know, 2 followed by 11, right? Because 25 times 2 is 50, and I get 11 as the remainder. So if I have 61 as my value of sense, then by what amount should I increase the coins variable by? So I need to increment the coins variable by this value, right? The sense that I already have divided by integer division in Python is done by this double slash, right? So that's just the semantics, that's just the syntax of Python. What we do is in Python, you use the double slash to represent integer division. So I'm going to integer divide sense by the denomination that I'm currently looking at, right? This is my current denomination, right, which I get from this array, and then that's going to be the increase of this coins variable. But how do you think sense this variable should decrease? Now to decrease this, so what should be the remaining value? The remaining value is simple, it's the remainder, right? It's this value. So if it was 41, I would have got the value, when I divide 41 by 25, I get the value 1 with the remainder of 16. So what I would say here is that I should update the value of cents by whatever the value of cents is right now, followed by an integer, not an integer division. This is the modulus operator. Cents modulo denom. Okay, so this is the remainder part. So 41 mod 25. So 41 integer division by 25 is going to give me 1, and 41 mod 25 is going to give me 16. So I need to mod this. So once I mod this, then I get my value. So instead of doing this, we could have also said, you know, this is the same as this. Okay, a mod equals b is the same thing as a equals a mod b. Okay, these two things are exactly the same thing. So that's pretty much it. I think this should work. Let's run this program. 0.41, and the answer is 0. Now why is that? Why is this happening? Well, the reason this is happening is let's see. Oh, the reason this is happening is first I need to initially I shouldn't change the value of coins. It's a cents. Cents should not be changed initially. Cents should be changed later on. I must first divide this thing, increment the value of coins, and then should I get the remaining value and store that in cents. Because cents, if I do the opposite thing, what I was doing previously was using 16, then I was dividing by 25, and that would have given me 0. Right? This is the logic. First, you look at what you need. First, you look at the number of coins that you need to increment this variable by. So to do that, you divide that by the denomination, and then you update the remainder, right? So let's try that out. 41, and the answer is 4. And let's just run check 50 on this. There's no check 50, but you know, if you are a little clever, you can say check 50 followed by this entire thing, and then you can just wait for this to happen. So that's pretty much it. I think this would be correct, but let me just try and check it out once. First, let me just review this entire thing once. First, you are just taking in a float. One bug was, you know, I had taken an integer here, but you should take a float here because you're asking for a floating point number. Okay. Next up, you say if the input that you've received from the user, if that's greater than or equal to 0, you break out. Then you round the dollar amount to the cent amount, and then you initialize the number of coins by 0, and then you can calculate the number of coins required, right? The minimum number of coins required to pay out that change. That's pretty much it. Like, share, subscribe.